right. So it says, suppose that you have the following information about a point on a graph of a continuous function. So suppose you have the following information about a point on a graph about a continuous function. What do you know about the point A, f of A?
It's an extrema.
Why?
Because the f prime of A equals 0.
Okay. So if f prime of A equals 0, you say it's an extrema.
Critical point.
Exactly. It is not an extrema. It is by definition a critical point. You cannot say that it is an extrema without a change in sign. So we could say that the point, well, that's what the definition of a critical point is. So f of A is a critical point by definition. Part B, f prime of A equals 0 and f prime of x is less than 0 on the interval from B to A. So if the interval is listed as B to A on like a number line, that means B is over here and A is here. That's why, I don't think your class ever really did it, but I had kids that in the past, they would write 8 to negative infinity, and I would mark them wrong because you cannot go from 8 to negative infinity. You read math left to right. So if the interval needs to be negative infinity to 8, you must write it left to right. This is incorrect and wrong, and would.
I wrote my points backwards.
What? No. The only time I would care is if it's a 0 and it tells you your domain is restricted. So the brackets matter when it's restricted. Does that make sense? Yeah. So it says from B to A, it is less than 0. So that tells me that this is negative on my number line. And so f prime is positive from A to C. So this is positive. So from B to A to C, B is greater than, or A is greater than B but less than C. That means that this graph is going from decreasing to increasing. So that means that the point A, f of A, is a relative or a local. That word is important. Exactly. Is a rel min or a rel max. If you were justifying why, then you're because.
F prime changes sign at point A.
Perfect. F prime of x changes sign from negative to positive at x equals A. Or if you want to write more words, at point A. Can you guys see that okay? Is that bright enough for you?
Yeah.
All right, part C, f prime of A equals 0, and f double prime of A is greater than 0. What test is this? Yep. So this is the second derivative test, because what they do is they give you a critical point on C, and then they give you the sign on the second derivative. So the second derivative test says that if the second derivative is positive, and the first derivative is a critical point, then A, f of A, is what?
Can I simply say this because of the second derivative test?
No,
Yes. I would still say the reasoning behind it. Yeah, like I would say A, f of A is a rel min by the second derivative test.
Where f prime of A equals 0 and f double prime of A is greater than
because f prime of a equals 0 and f double. I know, but it's like a proof in geometry, right? Like, but you still have to write it. In a proof in geometry, you still have to list the givens, even though they're given, right? And off of me. I didn't do anything. I'm just telling you how it is to get you your college credit.
You're just a passenger.
I am. All right, so F, sure.
About B. So could B be an inflection point too because it's changing or no? Because it's negative to positive, it's not increasing to decreasing.
And the next part.
F prime of A has to be an extrema, so that F double prime has to equal 0, not
Okay.
F.
And that's what I was just going to say. Part D is a potential point of inflection because the second derivative is 0. So you can't have a point of inflection unless either F prime is an extrema, like he just said, or the second derivative is a 0 or DNE.
I think I just get confused because I'm just writing like min and max, but that's about the original.
Everything we talk about is about the original, hence the A, F of A. So F double prime of A equaling 0 means that A, F of A, aka F of X, has a possible, hence the POI, point of inflection.
Because F double prime of A equals 0. And then, yeah,
Okay.
we're looking ahead, Corey dog.
So A is a PPOI. The second derivative is negative from B to A. So that means this is concave down. And F double prime of A is negative from A to C. So concave down. Therefore, A is not a point of inflection.
You would say it's not concave down because it's concave down the whole way, or would you say that like there's no change in concavity?
Yep, so A, F of A is not a point of inflection because F double prime does not change signs. Because you can only talk about the second derivative.
Alright, I like that too. Yo,
Yeah, that
just
works.
now.
Thank you. Okay. Now I want to look at graphs because I think you need help with
I
graphs.
do.
So we're going to look at two sets of graphs. The first sets of graphs we're going to look at is being given f of x, and I want to sketch f prime. Then I'm going to give you f prime, and we're going to sketch f.
I'm going to get in trouble for saying that one of these days.
I didn't hear you said that the recording did.
Oh, well, as long as no one other than
So
Desiree
no one's
watches the
gonna watch
recording.
Does well.
Yeah, she's going to be playing it on the TV, and D period's going to hear it and be like, what did he say?
I know she's gonna be watching it during GoPro, but she won't be back.
This is won't be there. Dawn won't hear it. Turn her in.
And then, no, and then Dawn will do what I say.
All right.
She's like, oh, that's a
So.
good idea. Turn it to this.
Given the graph of f of x, describe where f prime of x and f double prime of x are 0, positive, and negative.
Never.
So we are given the original. This is f of x. I know. So that's why I want to make sure. We're going to look at examples where we're given both, right? So we're given f of x.
The original.
So, if this is the original, everywhere you have an extrema on the original is going to be a...
F prime of x equals 0.
Exactly.
We're getting there, Corey. God. I smacked you. Don't take your mouth shut. Get there a little faster.
So did you ask when will f double prime equal 0?
And then I asked, how are we supposed to find when f double prime?
When it changes concavity. So where is the graph concave down? Where is the graph concave up? And where does it appear that it is perfectly in the center of the two?
0.
Perfect. So f double prime of x equals 0 at x equals 0.
What if they want like 0.05?
So if the original graph is increasing, then f prime of x, yep, so f prime is greater than 0, aka positive, when f of x is increasing. So that's on the interval negative infinity to negative 1 and 1 to infinity. Perfect. So f prime of x is less than 0 when f of x is decreasing. So, yes. Yes.
Yeah,
Yes.
because you must follow it exactly like this, and if every single one of your letters and words doesn't match up, you miss all points into the 0 and fail and die.
All right.
What is wrong with you then?
Where is f double prime positive? Perfect. So f double prime of x is greater than 0 when f of x is concave up, aka
With 0 to infinity.
excellent.
And you would start at that inflection point, right?
Yes. And f double prime of x is less than 0 when f of x is concave down, which is negative infinity to 0. So you want to do a crazy looking graph?
Yeah, let's do number 4.
Okay.
Because there's differentiability.
There are.
You
All right.
don't say.
They are. So at points like this and this, those are still critical points on f prime. But those are the critical points in which f prime
Doesn't exist.
does not exist. Exactly. So f prime of x does not exist at x equals negative 2 and positive 2.
Plus minus 2.
Yes. F prime of x equals 0 where? Correct. Yes, because it says describe where f prime of x and f double prime of x equals 0. So you would have to tell me nowhere. And since,
Technically, we wouldn't have to put the D in any part.
no, you did not, but I wanted you to understand it was DNE and not 0. Because a lot of kids look at that and they say, oh, it's extremas, it's 0. But it's not. They're critical points. They're not necessarily a 0. Okay, so where is f prime of x going to be positive?
When it's increasing,
Yep,
negative infinity to negative 2.
yep. Excellent.
Are you putting greater than equal to 0 or just greater than 0?
Greater, greater, greater. I would only have done an equal to if it was like number 2.
Or like whenever.
Because
we did
number
the example
2,
before, like,
this would be a critical point,
but not an extreme.
but not, but yes. So like at f prime of x equals 0, it would be at x equals negative 1, positive 1. Yeah, that's like a gross little number. Just going to call it positive 1. We're just going to say it's there. So it'd be at negative 1 and positive 1. because it equals 0 where the slope of the tangent is 0, which could also occur at a horizontal asymptote. However, on the intervals of like decrease or increase, now, unless you say f prime of x is greater than or equal to 0, or less than or equal to 0, you cannot include it in the interval. So like if we were talking, and this does say strictly positive or strictly negative, so number 2, it would be f prime of x is less than 0, but you would have to make your interval negative infinity to negative 1, negative 1 to 1. Like because at negative 1, it's 0, which isn't considered positive or negative. But in like that one homework problem, I included 0. Therefore, you could include it. But like and you're right, like it's all about how you write it. Now in this case, because I asked for 0, positive, negative, you cannot include it. Therefore, you cannot include it in our interval.
I was just confused on the one with Corey, the one where you like.
You could have.
Yeah.
So what Corey did wasn't wrong if he had just done it, like if he said this, positive, it's like not inclusive of 0. It's all about like what you do or don't include, and that's what makes it so difficult.
Yeah, but it doesn't change sign, so technically it's still...
But it's not 0. So it's not an extrema. But the slope of the tangent at that point is 0. Because this is horizontal. Therefore, m equals 0. M equals 0 on the derivative.
On the delta math, when I put it, oh no, that was asking for extrema, not increasing.
All right, number 4. Because then this part is tricky.
Because we don't know concave up to be.
So, yes. What's the derivative of a linear function?
A horizontal line.
Okay. So, technically, like, this is just a positive horizontal line, right? So, like, this would, we could just make this up, right? This would be a negative horizontal line. And this would be a positive horizontal line again on the derivative. Like I drew like the derivative graph. What's the derivative of a horizontal line?
0.
So, is f double prime of x positive? Is f double prime of x negative? Is f double prime of x equal to 0?
It's never concave up or down.
Yes, it's, yeah. So,
Because f double prime of x doesn't exist.
correct. So this has no concavity.
But it's not what it's asking us for.
It's asking for the positive and the negative, exactly.
So when f double
But it's also not ever positive or negative. It's
But
zero.
hold on. When
Whenever it
f
asks
double-
for 0, we would put f double prime equals 0 from
Oh.
negative infinity to positive.
No, it would be to the point where it does not exist.
It doesn't
Oh, so
exist
we
at
would have
negative 2 or
You
2.
would have to stop, like,
Yeah.
negative
Right,
infinity.
you'd have
Wow.
to break it up just like
You'd have to have
the
2
last
intervals. Yeah, 3 intervals.
Yeah.
So f double prime of x is greater than 0 and f double prime of x is less than 0 and nowhere. Or never, whatever you want to say. F double prime of x equals 0 from negative infinity to negative 2, negative 2 to 2, and 2 to infinity. So I said I really like this too, because it really helps make all those connections. Let's jump to if I give you the derivative, because 95% of the calculus graphs on the AP exam are derivatives.
Good, that's the easy stuff.
I'm glad you think so.
Easier. I love that easy.
Are you guys feeling better?
Yeah, I just want to get practicing.
I feel like I need to do Christmas break.
This is so we're already doing when f of x is increasing or decreasing?
I'm gonna justify everything that's wrong, but it's Christmas, so it doesn't matter.
All right.
This is literally the same worksheet that just says F prime now.
Exactly. But it changes everything.
It only says when it's increasing or decreasing.
Right.
So it's decreasing.
It's just when it's positive and negative.
Okay.
And then we
It's
can
super
do
easy,
that.
right? Let's do you want to do number 1 or number 2? You want to start with 1 and go to 2?
Yeah, let's start with
Or even 3? I like 3. 3 is good. So we'll do 1 and 3.
oh, okay.
Because 2, I think, is kind of... All right, so positive versus negative, right? It all has to do with above or below the x-axis. So f prime, if it asks you for this, that's f prime of x is greater than 0. Down here represents f prime of x less than 0. It's all represented based off the x-axis. So that means that this point, and this point are all
Extrema of F.
exactly. And they're all extrema because there is a sign change at every single one of them. So f prime of x is positive.
We don't need anything on F prime, but we just need where F of X is increasing.
How do you justify it?
Well,
Yeah.
I like starting with the F is increasing.
Fine. F of x is increasing on the interval
I start with
negative 2. It just assume it's at negative 2. I just sort of,
that's right.
Microsoft Word's not always my friend. Negative 2 to 0
2 to
and 2 to infinity. Because,
F prime of X is greater than 0.
excellent.
Can we just put f on of x is positive?
Yes.
I'm not messing around with the sign.
Corey's not messing around. He's taking this test serious this time. Last test
Okay.
was a joke.
F of x is decreasing
Oh, it was a joke, alright.
negative infinity to negative 2 and 0 to 2 because f prime of x is negative. Does that make you happier?
Yes. 'Cause I know me, and I know when I get to the test, I'm going to switch the signs around for something.
If I extended that and asked you where does f have a local max and where does f have a local min?
So that's a max when it goes from positive to negative.
Yeah. So that
It
would
equals
be
0.
Exactly.
So that would be at 0. Negative 2.
No, because it only goes from positive to negative once.
So it has to go from increase to decrease, which is positive to negative. So that's at 0 because it's going positive to negative. So here, this graph is going
But what about
from negative.
Oh, I was reading it right to left.
Yep, this graph's going negative to positive. So that means that that is a min. And this graph is going negative to positive. So that makes this a min.
We have to justify that last line.
Yes.
The f of x is over the max of x equals 0.
Yes, because f prime of x equals 0 and changes from positive to negative. Not only does it change signs, you have to tell me what signs.
I can just say it goes from positive to negative. I don't need to say it changes signs from positive to
Correct. Do you want to look at 3? All right. So anytime I get a derivative graph, I auto mark in my zeros.
Are we assuming that to be 2 again?
Do you want to just assume that? Because it kind of does bug me.
I don't want to use 2 and 1/4.
Yeah. So we're just assuming this is at 2.
But I also know what happens when you assume.
Makes an ass out of you.
Why do you have to swear on the recording, Blaze? That is
I'm sorry.
so unprofessional. Are you going to swear in front of a court judge?
Well, I want to be the judge, so.
All right. So even though we have 3 zeros, which all act as critical points, that means that at x equals 0, it is not an extrema. And for you, we're going to actually do the concavity from this too, because I think that's where you struggle a little. So where is f of x increasing? So f of x is increasing when f prime of x is positive.
So this is where my question is again. Would I stop and make it
Yes.
separate interval? Okay.
No, well, this one you don't have to. Yeah.
That's why I'm like.
It's safer to stop than not stop.
Okay.
Like I always say, like, be safe. So, like, I would go -3 to 0, 0 to 2.
Okay.
Excuse me.
Sorry.
Uh-huh.
How do you know?
I know. I knew the minute I left in my mouth. I was like, crap. Like, that's just
What happened?
nothing.
Nothing.
F of x is decreasing when f prime of x is negative. So that's -infinity to -3 and 2 to infinity. Since we're not doing 4, I'm just writing all the way across. Because I want to use the space below for something else. So, extrema-wise,
The extrema.
f of x has a local min. So a local min. If you, again, you could do your sign chart too, right? So like if you made this your sign chart, this would be negative, positive, critical point, positive, negative. Like sometimes, like, you know what I mean? I think that helps you to see that too. So that means it's decreasing, increasing, increasing, decreasing. So x equals -3 is our, yeah. Because f prime of x goes from negative to positive. And then f of x has a local max. Exactly.
On the test, am I allowed to abbreviate negative and positive?
Yes. Because f prime of x goes positive to negative. So we have increasing, decreasing, local max, local mins. X equals 0 is a critical point, but it is not an extrema. Yep, so this is just a CP. Doesn't do me any good.
And then the changes in concavity are possible.
So let's talk about concavity. If you're given, those are the point of inflections.
That's what I said. That's what I
Yeah.
meant.
So where we have an extrema on f prime will give me my concavity. So really what we're looking at is where does f prime change from increasing to decreasing. So here, f prime of x is increasing, therefore
Concave up.
f of x is concave up. I'll say -1.5. Where else is f prime of x increasing?
0 to 1.25.
Or 1.5, but yeah.
And then the changes in concavity, like those points, are where
So negative 1.5 and 1.5 and 0 are all points of inflection. No, they are points of inflection because exactly it changes from increasing to decreasing or decreasing to increasing.
But we can say just because f prime is increasing, right? We don't need to say it changes.
Correct. Well, no, you could just
But
say,
if we were verifying
you could
they
say,
were a point of inflection, we would say it goes from concave up to concave down because f prime goes from increasing to decreasing.
or vice versa.
Okay. But just for saying where it's concave up, we don't need that.
Correct. So like concave up is just the intervals where f prime of x is increasing. Concave down are the intervals where f prime of x is decreasing. So negative 1.5 to 0, and then 1.5 to infinity. And then POIs at x equals negative 1.5, 0, and positive 1.5 because f prime of x goes from increasing to decreasing or vice versa. I just ran out of paper. I'm sure you did too.
Because f prime goes from f prime goes from increasing.
Okay, so I have a worksheet for you with a table.
It's just a worksheet of mine. It's the book that gets it.
No, it's the top that needs your worksheet. But you gotta drink some coffee here.
I did last night, and
I'll do it again.
it kept me up till 4 in the morning.
What? That doesn't make sense. Did
The
you
cough
spike it with
syrup?
caffeine?
The cough syrup or
Well,
the cough?
It was probably the cough itself. Well,
Alright guys, 1, 2.
I was up till 2 anyways, doing like calculus and the lit notes and stuff, so.
10 minutes.
No,
I did it before my trip.
multiple. We played 4 days. Did you do well?
So there's 4 multiple choice, 1 table, and then I'm going to have you guys do 2 out of the book.
Look up there.
2 out of the book because I want to spend period 1, like half of period 1 tomorrow kind of going over this, and then we'll take our quiz. The only thing that's like not on here, which is what I was trying to find in the book, is like if I give you a function.
To talk about rheumatoid arthritis presentation.
Because that's in the lungs and that has nothing to do with the muscles.
Rheumatoid?
Rheumatoid is in your lungs.
It's in your joints.
That's just regular arthritis.
Yeah, regular arthritis is called rheumatoid arthritis.
The problem with that system is that it encompasses so much that like you only have.
And also, I couldn't care less to talk about it.
All right, so in the book,
Joint inflammation, that's all it is.
I want you to do problem,
Yeah, but it's literally
so
just
page
inflamed joints.
229.
How long am I going to spend on that? 4
Look
days?
at problem 14 to 18, like 14, 16, and 18. But I want you to do everything. Because it only asks you for the point of inflection, but like tomorrow I want to go over it. So I want to talk about like where is it increase, decrease, locomax, locomin, concave up, concave down, POI. Like all 6 critical points.
What page is it?
229.
Yeah, 229, 14, 16, and 18. But give me increase, decrease, extremas, CU, CD, POI. Does that make sense?
Yeah.
And then I'm going to work it all out and have it all on a handout too. And I'm going to photocopy it. So when you come in, you can check it, go over it. And then we'll talk about the answers to these handouts, which I already have the answer keys to them as well. Like, would it be more helpful if you had the...
No. I'd rather wait till tomorrow.
I'd rather figure it out myself.
What if I tell you the answers to the 4 multiple choice, just like the multiple choice answer, so you know you get the right multiple choice
You
answers?
send them in team chat and not just like announce them right now.
Hmm?
Yeah, that works.
But would that be like helpful if I tell you like 1 is D, 2 is A, 3 is D, so that way like you can make sure your work matches to that, but like I'm not giving you the work. Okay. That way it's kind of like the answer without being the answer. All right, guys. Thank you.
Have a nice day.
Oh, by the way,